My sword glows, energy flows through it, the edges shine, but it still looks too clean. Too perfect, like it has been made in a factory. Can we make it look like it was forged in the deepest pits of hell?
Absolutely. Today we're going to turn this magical sword into something that looks dangerously hot, not just glowing, molten.
Excellent. Nothing says don't touch quite like a sword that's still liquid.
Here's our sword from the previous lesson. The glow looks nice, but every edge glows exactly the same. Nature almost never behaves like that. Think about hot metal in a blacksmith forge. Some areas are bright yellow, some are orange, some are already cooling down. The heat constantly shifts around. If every pixel glows equally, our brain immediately notices that it looks artificial. So today we're going to add natural variation. And the secret ingredient is a node called simple noise. Create node, search for simple noise. Place it anywhere in your graph.
What the hell is noise? Like sound noise? Or something else?
Not quite. Noise is a mathematical pattern that looks random. Notice something important. We didn't import a texture, we didn't download an image. The GPU is calculating this pattern every frame using mathematics. That's why we call it procedural. Instead of reading pixels from an image, the shader creates the pixel itself. Because it's just math, we can animate it, stretch it, combine it, or use it as a mask. That's why noise appears everywhere in computer graphics. Fire, smoke, clouds, water, lava, electricity, corruption, magic, train generation, vegetation. Once you recognize noise, you will start seeing it in almost every game you play.
Okay, so half of modern graphics is just fancy math pretending to be nature? Huh.
That's a surprisingly accurate description. Let's experiment before connecting anything. Select the simple noise node. We'll notice it has a scale input. Create a new float property, call it heat scale. Connect it to the scale input. Now increase the value. The patterns becomes much smaller. Lower it. Now the shapes become much larger.
It looks like television static. Did the shader lose signal?
Right now the pattern is completely static. Real heat never stays still. Let's make it move. Create the following nodes: UV, tiling and offset, time. Create another float property called heat speed. Multiply time and heat speed. Connect the result into the offset inputs of the tiling and offset node. Then connect UV to tiling and offset. Tiling and offset to UV inputs of simple noise. Save the graph. Change the value of heat speed. Now we should decide where should the heat appear. We already created a Fresnel effect in an earlier lesson. Today we're giving it a completely different job. Instead of creating magical glow, we'll use it as a heat mask. Remember what Fresnel does? It becomes brighter near the edge of the object. That's exactly where we want the hottest metal.
So we're recycling old nodes now.
Good shaders recycle ideas all the time. Right now, we have two separate pieces. The Fresnel tells us where the heat should appear. The noise tells us how the heat should vary. Now we combine them. Create a multiply node. Connect Fresnel to the A and simple noise to B. The result becomes our new heat mask.
Oh, now every edge isn't glowing equally anymore. Some parts are brighter than others.
Exactly. Think of it this way. Fresnel defines the location and noise defines the variation. Together they create something that feels much more natural. So today we learned much more than a molten sword effect. We learned how to use a procedural noise. We animated it by scrolling UV coordinates. We reused a Fresnel effect as a mask. We combined multiple masks using multiply. We built the entire effect without importing a single texture. Everything you see is generated by mathematics directly on GPU.
So, my sword is basically algebra with anger issues.